Hello. I just want to share with you my understandings of what the math operators divergence and curl really mean in the context of Maxwell equations. We're going to revisit briefly the Maxwell equations, and we will talk about the reasons why we need to have these operators, I think, and then getting into more details about the definitions and the meanings of all of these del dot and del cross and so on. To explain that thing further, we'll have to talk about the two integral theorems, the divergence theorem and Stokes theorem, and then explain the through some sort of visualization to see why it makes sense to see that these theorems are considered to be correct, right? And then we're going to do a recap. Now, here on the left side, we have the differential forms of the Maxwell equations, and on the right-hand side, the integral forms of the Maxwell equations, and they are equivalent. Hopefully I don't make any mistakes on any of these things. Now, why do we need these del cross and del dot, which is the divergence and the curl? When we talk about the integral forms, this explained at a high level, like when you talk about, for example, the case of divergence of D here, which is this case. We talk about a volume, we talk about a surface, then the surface basically encloses completely the volume, and we talk about it in general terms, and that could be really big volume, could be very small volume. But when we talk about specific things in a situation where we want to explain and do calculation and do modeling and so on, the volume way is not a good way to solve the problem. So that's the reason why the divergence operator, del dot, is, I think, was invented or conceptualized to make life easier to do the modeling, to do the projections and so on. Whereas the integral form, which explains better what it really means at a general scale, right? So that's what I believe things are. And how would that help? When we talk about something like a volume like this, we can talk about a volume this big, or we can shrink the volume to a infinitesimal small, like a dot. And that's when we can treat the concept to be an ensemble of many dots that are unique, and therefore we can model better any situation or most situation that we encounter. And that's the reason behind the use of these operators of del dot, divergence, and del cross, curl. All right, so next we're going to go to the second half, which is the definitions and the meanings of these operators and how they fit together with the integral theorems and so on. All right, well, thanks